Hey everyone, welcome back. Before we plunge into the profound and surprising depths of today's cosmic topic, I'm sending out a huge wave of positive energy and the very best wishes to all of you tuning in. Wherever you are in the world, I genuinely hope you're feeling fantastic, taking excellent care of yourselves, and staying healthy. That's truly the foundation for enjoying the wonders we're about to explore. Now, close your eyes for a second and picture the vastness of space. What do you hear? Most of us imagine an overwhelming, absolute silence, a profound, eternal quiet stretching between the stars. It's a common image reinforced by countless sci-fi movies, the vacuum of space as the ultimate silent void. But here's the astonishing truth that shatters that perception. Space is not completely silent. While the near-perfect vacuum between celestial bodies does prevent the sound waves we experience on Earth from traveling, there's a hidden layer of cosmic noise humming and crackling across the universe. Certain frequencies of sound can and do travel through the cosmos, carried by an extraordinary state of matter called plasma. It's a revelation that transforms the silent movie of space into a symphony playing on frequencies we're only just learning to tune into. To understand this cosmic sound, we first need to grasp why we typically think space is silent. Sound, as we know it on Earth, is a pressure wave. It needs a medium, like air, water, or solid ground, to travel through. When you clap your hands, you disturb the air molecules nearby, causing them to vibrate. Those vibrating molecules bump into their neighbors, transferring the energy along in a chain reaction, creating waves of compression and rarefaction that eventually reach your eardrums. Space, however, is mostly a near-perfect vacuum. The density of atoms and molecules out there is incredibly low, often just a handful per cubic centimeter, compared to billions upon billions in the air we breathe. With so few particles floating around, there's simply nothing substantial enough to bump into its neighbor effectively and carry those familiar pressure waves. So, if you were floating in the void between stars, without a spacesuit, you wouldn't hear an explosion nearby or the roar of a starship engine. The vacuum acts as an incredible insulator against the type of sound our ears are built to detect. That part of the silent space image is absolutely correct. But here's where things get fascinating. Space isn't truly empty. It's filled with what we call the interstellar medium, ISM, or intergalactic medium, IGM. This isn't just random atoms drifting alone. A significant portion of this matter isn't in the familiar solid, liquid, or even gaseous states we know. Instead, it exists as the fourth state of matter, plasma. Plasma is essentially superheated gas that's been energized so violently that the atoms themselves get torn apart. Electrons are ripped away from their parent atoms, creating a swirling soup of free-floating, negatively charged electrons and positively charged ions, the leftover atomic nuclei. Think of it as a gas that's been zapped with so much energy that it becomes electrically conductive. The sun is a giant ball of plasma. Stellar winds streaming from stars are plasma. The vast spaces between stars within a galaxy, and even the mind-bogglingly huge voids between galaxies, are permeated by incredibly diffuse, but ever-present, plasma. Plasma behaves fundamentally differently from a neutral gas. Because it's made of charged particles, electrons and ions, it interacts powerfully with magnetic fields. Magnetic fields are invisible lines of force that permeate the entire universe, generated by moving electric charges, like the churning molten metal in planetary cores, the flow of plasma in stars, or even the movement of charged particles themselves across vast distances. These magnetic fields are like cosmic puppet strings. When charged particles in a plasma move, they generate magnetic fields. Conversely, existing magnetic fields exert forces on charged particles, pushing and pulling them, guiding their motion. This intimate dance between charged particles and magnetic fields is the key to unlocking sound in space. In a plasma, sound doesn't travel as simple pressure waves bumping neutral atoms. Instead, sound travels as waves in the plasma itself, driven by electromagnetic forces. These are often called magnetohydrodynamic, MHD, waves or plasma waves. Imagine the plasma as a vast, invisible ocean. If you disturb this ocean, say, with a solar flare erupting from a star, a supernova explosion, the collision of two plasma clouds, or even the powerful jets shooting out from a black hole, it creates ripples. But these aren't just ripples of density like water waves. These ripples involve coordinated motions of the charged particles guided and influenced by the embedded magnetic field lines. The particles don't just randomly bump, they move collectively, sloshing back and forth along the magnetic field lines or compressing and expanding the field itself. This coordinated motion propagates through the plasma as a wave, carrying energy and information, essentially sound. The magnetic field acts like a taut string that the waves can travel along, even through regions where the plasma density is very low. Without magnetic fields threading through the plasma, these kinds of waves couldn't exist or propagate effectively across interstellar distances. So, what does this space sound actually sound like? Well, we humans couldn't hear it directly even if we were floating in it, and survived. The frequencies involved are often far below or far above the range of human hearing, 20 Hz to 20,000 Hz. Many plasma waves are extremely low-frequency rumbles or ultra-high-frequency whistles and hisses. But here's the incredible part. Our spacecraft are equipped with sensitive instruments designed to detect these electromagnetic waves. Probes like NASA's Van Allen probes, studying Earth's radiation belts, the European Space Agency's Cluster mission, NASA's Parker Solar Probe, diving into the Sun's atmosphere, and Voyager, now in interstellar space, carry antennae and sensors that can listen to the electromagnetic emissions generated by these plasma waves. Scientists can then take this data, which is essentially recordings of changing electric and magnetic fields, and convert it, or sonify it, into audio frequencies our ears can perceive. This process is like shifting the pitch of a record way up or way down so we can hear it. The results are eerie, beautiful, and profoundly alien. One of the most famous examples comes from right here in our cosmic backyard, Earth's plasma sphere. This is a region of relatively cold, dense plasma trapped within Earth's magnetic field, extending thousands of kilometers above the atmosphere. Within this region, particularly in the radiation belts, spacecraft have detected strange electromagnetic emissions. Among them is the haunting chorus. Sonified, it sounds like birds chirping or dolphins whistling at dawn. These rising tone whistles are caused by electrons spiraling along magnetic field lines and interacting with plasma waves. Another sound is the hiss, a steady, static-like noise generated by plasma turbulence. Then there are whistlers, sounds that start high and rapidly descend in pitch, caused by lightning strikes on Earth sending electromagnetic pulses up through the ionosphere and into the magnetosphere, where they travel along magnetic field lines. Listening to these recordings is like tuning into Earth's own space weather radio station, broadcasting the complex interactions between our planet's magnetic field and the solar wind. Venture further out, and the sounds become even more dramatic. Our sun is a cacophony of plasma waves. The churning, superheated plasma in its outer atmosphere, the corona, and the solar wind streaming outwards are filled with vibrations and oscillations. Scientists sonify the vibrations detected in coronal loops, giant arches of magnetized plasma, revealing deep, resonant hums or gong-like sounds, helping them understand the sun's magnetic structure. Jupiter and Saturn, with their powerful magnetic fields and volcanic moons, like Io, generate intense plasma waves in their magnetospheres, creating sounds ranging from crackles and pops to eerie whistles and roars. Comets, as they approach the sun and release gas that turns into plasma, create a distinct buzzing sound as their ion tails interact with the solar wind. Even the seemingly empty space between planets and stars hums with the ultra-low frequency waves generated by the turbulent motion of the solar, or interstellar plasma itself. Perhaps the most mind-blowing example of cosmic sound comes from the unfathomably large scales of galaxy clusters. Galaxy clusters are the largest gravitationally bound structures in the universe, containing hundreds or thousands of galaxies, vast clouds of hot gas, which is plasma, and enormous amounts of dark matter. The Perseus Galaxy Cluster, located about 250 million light-years away, contains a supermassive black hole at its center, actively feeding and blasting out powerful jets of energy. This energy creates immense pressure waves that ripple outwards through the incredibly hot, millions of degrees, intercluster plasma, the thin but pervasive plasma filling the space between the cluster's galaxies. These pressure waves are true sound waves traveling through a medium, the plasma, albeit at frequencies millions of times lower than human hearing. In 2003, astronomers using NASA's Chandra X-ray Observatory detected these ripples as subtle variations in X-ray brightness across the cluster. The period of these waves? One oscillation every 9.6 million years. That corresponds to a note about 57 octaves below middle C on a piano. Sonified by shifting the frequency up by an astonishing 57 or 58 octaves, this cosmic hum becomes a deep, resonant B-flat, more than 1,000,000 billion times higher than its original frequency. It's the deepest note ever detected in the universe, a basso profundo vibration resonating for hundreds of thousands of light years, generated by a black hole's roar and singing through the plasma ocean of an entire galaxy cluster. It's a sound that has been traveling since the time of the dinosaurs, a testament to the sheer scale and power of cosmic processes. Discovering and studying these plasma sounds is far more than just a cosmic curiosity. It's a vital tool for space physics and astrophysics, a way to diagnose the invisible. By analyzing the frequencies, amplitudes, and patterns of these waves, scientists can learn crucial details about the environments they pass through. They can determine the density of the plasma. They can measure the strength and direction of magnetic fields. They can understand the temperature and the velocity of plasma flows. They can trace the energy transfer from explosive events like solar flares or supernovae. They can study the stability of structures like planetary magnetospheres or the accretion disks around black holes. Plasma waves act as messengers, carrying information about the physical conditions in regions we can't physically visit. They reveal the dynamic processes shaping the cosmos, from the protective bubble of Earth's magnetosphere shielding us from solar storms, to the violent jets powering distant quasars, to the gentle ripples echoing through the intergalactic void. So, the next time you gaze up at the silent stars, remember that the stillness is an illusion crafted by the vacuum. Beyond that quiet, an invisible sea of plasma churns and surges, threaded with magnetic fields. Within the sea, sound waves propagate, deep hums, whistling electrons, chirping chorus, and the resonant B-flat of galaxy clusters, carrying the vibrations of cosmic storms, stellar winds, and gravitational behemoths. Space isn't a silent movie. It's a grand, ongoing concert playing on electromagnetic instruments, broadcast on frequencies beyond our natural hearing. Thanks to our intrepid spacecraft and clever scientists, we are slowly learning to translate this electromagnetic symphony into sounds we can perceive, transforming abstract data into an auditory experience that connects us viscerally to the dynamic, singing universe. It's a profound reminder that even in the apparent void, the universe is alive with vibration and energy, a complex chorus conducted by the laws of physics, playing out on scales from the subatomic to the galactic. It's not silence. It's a song we're only just beginning to hear. Thanks for listening to the Sounds of Space with me today. Stay curious, stay healthy, and keep your ears and mind open to the wonders of the cosmos.